Hello, welcome to Automat Live Coding. It's the stream where we write Automat. Let me quickly show you Automat. Automat is a tool for macros, for game automation. In this tool, you get access to a bunch of toys. And you can build tiny machines out of those toys. So here is an example of a toy. This is a hotkey. When I press F1, when it's powered on, it will send a signal. This is called control flow. So this control flow can be passed to another toy and activated. So here, for instance, or I will actually do this in a more complex way, because this would be simple. This way I could activate macro recorder by pressing F1. But I will do this differently. I will connect it to a switch. So I have a switch that flips whenever I press F1. So yeah, that's a fun mechanism. Now I can connect macro recorder. I can synchronize the state of macro recorder with this switch, so that whenever switch is on, macro recorder is active. That's another fun technique. And now I can create a macro. This is a longish macro. I will cut this a little bit so that it looks like that. And this is my macro. This is a macro where I moved my mouse and then I pressed the F1 key. I will delete this F1 key because I do not want this to activate again. And I do not need this macro recorder. So I can delete this using the bubble menu, but there is another way to delete stuff, which is throwing them into the black hole in the corner, which I like more. I also do not need this switch, so I will get rid of this, and I will instead connect F1 to this macro. So now when I press F1, my mouse will do this, and I move. I can make it shorter, like that. Now I press it, and it moves my mouse. And this macro is kind of slow, so maybe I will cut this section as well, like that. I want this macro to execute very fast. I'll cut some sections. Here. Here. And maybe I will also make the macro short. Oh, and there is another gap here. So when you're doing macros in games, like cutting those gaps makes them very, very fast. You know, when I play this now, you can see that the mouse moves just incredibly fast. It's very hard to stop your mouse instantly like that. But this macro, because it's, you know, we can control it. We can get rid of those tiny gaps here. So that it's faster. And this is useful in some games. If a game has a repetitive element where you have to, I know, constantly fight some enemies, when you have to activate some skill at a timeout, then it's nice to have those automated tools that will do this for you. So it's for playing games, but this tool is growing and growing, so it can do more than playing games now. You have access to a bunch of fun and low-level instructions. So those cards here, they contain a lot of commands. They are called instructions. You can invoke those instructions. Those are very fast, very low-level things that your CPU can do. This is not some kind of fake artificial language. Those are actual instructions. So when I run this, you will see I can, maybe I can do this. Oh yeah, I can randomize the contents of a register here. It's not updating properly. Maybe I should take care of this. Anyway, our plan for today is to, yeah, there you go. This is how fast we can increment stuff. And the fun thing is that this environment, it follows a very interesting architecture where, you know, the things that you can see on screen, for example, this register in the menu, you can see that the menu icon is also animated, you know, and when I pull it out, it's also animated. This is because all of those on-screen widgets, they all refer to the same kind of abstract object in a memory of a computer, like a register. So they... so many bugs. So they kind of update instantly. And if you look at how fast they update, like this counter, it is incrementing by 1 during every cycle of the CPU. And the CPU executes like 5 billion cycles per second, so it's like executing 5 billion times per second. It's very fast. I would even dare to say it's probably faster than Factorio in terms of, you know, how it executes. Because it actually executes machine code. This is the actual machine code within the CPU. We have all sorts of other tools, like the ability to capture screenshots. Hey, check that out. It's Automat within Automat. And you can also start commands. I can run Firefox, for instance. And this is Firefox inside Automat. Maybe I will not run Firefox. I will run something else. Emacs? Oh, Emacs is much nicer. And I think I can force the app to decorate itself. Okay, it's a mistake. Apparently Emacs cannot self-decorate. Yeah, not a big issue, not a big issue. This is actually fun. I could probably play with the dithering, so that instead of using linear, bilinear, I could use something cooler here. Anyway. So during last stream, we've been working on this object. We've been trying to optimize it so that it renders faster. You can see it has those funny fuzzy edges, gradients around the edges. And those gradients were actually killing performance. It's actually very slow. It's very hard to draw them in a responsive fashion, but, you know, we found a way. Now it is fast. Even on my laptop, it now draws responsively. So yeah, I'm kind of happy with this. Not everything is drawing responsively, but yeah, we have to balance optimization, bug fixing, and new features. So on Monday, we have been doing optimization. On Tuesday, I haven't been streaming, but I have been working still on stuff. So I have been working on a new shadow system. So you can see shadows. If you look carefully, you will see they have some kind of fuzzy pattern to them. This is because there is this new shadow system which allows me to, when I grab an object, it will cast a shadow on the background and on other objects below this. But if I drag a stack of objects, they will drop a shadow, you know. They will not self-shadow. Oh yes, this is what I mean. Self-shadowing is not a problem anymore. Okay. This is a fun machine. You can probably guess what it does if you look at it. Here we have 3 timers in a sequence, and each of those timers is synchronized to one of the switches. But really, this demo is not about those timers. This demo is about those connections. Because if you look at them, they are not sorted in a logical way, like they form a cycle. Like this object, this switch here on the top left, it's on top of this one. If I drag it, you can see it's on top. It's on top. But this one on the bottom, it's on top of this one. See, it's on top. And this one, it's on top of this one. So they are... One of them is actually on top. And you can probably only see how it works if you... Actually, you cannot even see how it works. It actually recovers. But yeah, you can form those funny, non-physical stacks of objects.
Meister Chica says,
See, that's I told you.
Hey! Yeah, so we can form this like 4-dimensional spaghetti of connections, which is typically bad. But we have this other mechanism now where I can create a clone of this object. And a clone, I don't know why it's lagging for some reason now. A clone is... This is basically the same object, and there is a limitation. I cannot really have the same object in two different places here on the same board. But if I pick it out to a new board, I can put it here. So I can have clones of those 3 switches here.
Have you seen this article?
URL.
Yeah. And now the switches are... There is no spaghetti anymore. I have like a separate board without spaghetti. Check this article. Multi-call programming, not as a special case technique, but as a new dimension in all code. Sounds interesting. I am going to read this. Ryan Flory, I think I heard this name. Ryan Flory. I remember this name. I think he wrote something. Maybe he has a good programming blog or something.
He was on BSc last year.
Yes, see, this is some kind of handmade community.
Better software conference, don't you?
Oh, yeah. I like all stuff debuggers. Okay, I think we are going to like this guy. I can already tell you. Let's check this stuff. But before I do this, I want to take a note of a couple things, like bugs. I noticed some bugs when I was playing with this. There was... then Spotlight draws over its endpoints, and I think I've seen more issues. Yes, Okay, the plan for today is mostly to fix those bugs. Those are small bugs, but they kind of pain me whenever I have to use Automat. It's like... I just do not want to show this because it has those bugs. I just want to fix them. I want to have a clear mind, not worry about them anymore.
Wait a minute. Where's MX? Did you switch your euros?
This stuff here, this is one of the most insane pieces of technology that you've probably seen in a long time. So this thing is called Patchwork, and Patchwork is a distributed computer. It is based on the web infrastructure, right? It runs within a web browser, but the idea here is that this computer, it can actually execute code. It has multiple kind of apps in it. Like, those are multiple apps. I can open TLDraw, like a new TLDraw canvas.
So Emacs put on the web?
Like, this is, like, the crazy part about this thing is that this is kind of my own, like, local Patchwork computer. I can synchronize this with my phone, and they will have a copy of the same computer. And under the hood, this is using a storage format based on very fancy data structures, which can be always synchronized in a consistent state. So even if I have this computer running on several different machines, when they meet, when they join together, all those separate computers, they will always synchronize their memory to a consistent state. So it's impossible to desynchronize them. Like, it's actually physically impossible to break them because of the properties of this structure. So I can have like a TLDraw canvas here. I can have the same on another computer. And actually, I can also see how it looks, internally. So this is the internal representation of this. So I can basically use this computer on several machines, and they kind of join together, synchronize, and continue, carry on, as if it was a single computer. It's a crazy piece of technology. It's a very, research-grade software, but it is a pretty insane thing. And Patchwork, I am switching to Patchwork because I want to put Patchwork within Automat. So that within Automat you will be able to use this synchronized kind of abstract computer, which is kind of out there, nowhere, kind of. It's not really hosted on any server. It's kind of hosted in a distributed fashion.
Where can I find that thingy?
This is the website. The website does not do it justice. There aren't many explanations here, but there are some kind of research notes published on this website. There is no good write-up yet. Probably. Anyway, this is non-commercial software. This is a research software. And it is incredibly insecure. I've heard some people saying this is insecure, like even the authors keep saying it is insecure. I disagree. I think this is perfectly secure. It's just the idea is that it's a distributed computer, and when somebody else is also having their own distributed computer, and you synchronize them, you create a kind of a bridge between them, suddenly the two of you are using the same computer because the two computers kind of synchronized. They form a single computer now, and both of you have equal access to it. You know, at this kind of mathematical level, there is of the data structure which works under the hood of this. There's really no difference between. This computer is not aware of users. Once it's synchronized, it doesn't care about somebody being malicious or not. There is some elegance in this.
Nexus says,
So backdoor.
Hey. This data structure, this is called CRDTs. It has some. It's very nice for data synchronization, but it has a very big security flaw. It's that anybody can pretend to time travel. You can say, oh, I modified this document 1,000 years ago. So everybody who sees such an update, such a malicious crafted update, kind of has to honor it. Because if they don't, the properties of this computer, they fail. It's no longer distributed then. So everybody has to keep the whole history of all edits, which is kind of expensive. And everybody has to honor backdated updates, which opens a lot of security rabbit holes. So it's not practical for adversarial scenarios, you know, when there are malicious users around. But you know, as long as you do not share any data with anybody, this computer is actually pretty robust, pretty secure, I would say.
Meister Chica says,
Speaking of cool new stuff,
URL Nexus says,
it can't be worse than Windows 11 with Git, right?
Interesting. I am saving this for later. GitHub's diffs are kind of. They aren't bad, actually.
I was watching video on how Kerbal was made.
Let me check some examples. That's looking nice. I hide the sidebar. No. Sidebar is required. Decent. Diffs hub. I am starting this one. Thanks.
Meister Chica says,
It has Puer also.
Yeah, I just noticed it was like asking me to install my desktop. Okay, I just wanted to register some of the bugs, and I want to get back to this stuff, because this looks interesting.
Nexus says,
Turns out the original guy left who came up with Kerbal. That's why Kerbal 2 was bad and died.
Yeah. There is other game that kind of... There is actually more than one games that kind of follow the Kerbal legacy. They are not as good. There is Juno New Origins.
But he made Kitty Space.
And there is the other one with kitties. I would say this one, this Juno, is slightly more about, you know, hardcore engineering funny machines and making them, you know, do stuff. It's less about funny, just putting, you know, Pokemons in space, and more about simulating funny machines. And I also like it because it has a built-in kind of programming system where you can script your machines, because once you build something too complex, it's hard to control. So you can build your own controllers that effectively drive those machines for you. You can basically say, oh, there is a waypoint there, and you can have your program basically navigate the machine.
I am familiar with Simple Planes 2. Was my first game I bought on Steam.
Yeah. I think this is a rebranded Simple Planes 2 or something like this, or maybe like another version. It's called, I think those are the same developers. Yeah, this is how their kind of programming system looks like. Sorry. Not this. This is it. It's based on Scratch, I think. But it works nicely. Yeah, very positive. I agree. It is a very, very good game. But the aesthetics are so boring. You have those astronauts. This is basically your character. It's so meh.
It's cool to be able to build what you want, like in real life, but without spending millions of dollars.
So, on the technical level, this is the true successor to Kerbals, but on the, like, silliness plane, the Kitty Space Program is probably the right successor. And honestly, if I had to pick some, like, theme or like lore put in this universe, I wouldn't go with kittens, because kittens, I think they are overused. They feel cheap. It's almost like a trope. Everybody's just using kittens, make stuff silly. I think something like birds or dinosaurs, maybe using rackets would make sense. You know, there's some unexplored irony in birds learning to fly using planes.
Meister Chica says,
Oh no! I just mad recurring payment of 659.61 USD. I don't use PayPal.
Wow. That's a big recurring payment.
Dux Nexus says,
I was playing Raid Game today.
Rage game.
9 souls.
Meister Chica says,
Those scammer are really playing a big number game.
Was it a scam? You had some kind of small subscription that exploded into $600? Okay, this is a longish article, but I think we can dive in. I will mute the test. Okay. Learning to program a single CPU core is difficult. There is an enormous number of techniques, amount of information, a number of hours to spend in order to learn to do it efficiently. Learning to program multiple CPU cores to work in parallel, all while these cores cooperate in accomplishing some overarching task. To me seems like an anvil that broke the camel's back, so to speak. It's already too much to wrangle when doing single-core programming, but for me, it was much more convenient to ignore multi-core programming for a long time. Yeah, and there is also a penalty tax that you pay when you want to use multiple cores. The synchronization is kind of slowing down the execution, essentially. But in the modern computer hardware era, there emerges an elephant in the room. With modern CPU core counts far exceeding 1, and instead reaching numbers like 816, 32, 64, programmers leave an enormous amount of performance on the table by ignoring the fundamentally multi-core reality of their machines. I'm not a performance programmer like Casey Muratori, which is partly what made me follow him to begin with. I have always wanted reasonable performance, though this might appear like performance programming to a concerning proportion of the software industry, but historically, I've worked in domains where I control the data involved, like my own games and engines, where I am either doing the art design or levels myself or heavily involved in the process, as I've often been able to use my own programming constraints for artistic constraints. Okay. All of that went out of the window over the past few years when in my work on debuggers, I've needed to work with data which is not only not under my control, but is almost exactly identical to opposite of what I want. It's dramatically bigger, unfortunately poorly structured, extraordinarily complicated, and not to mention unpredictable and highly variable. This is because, as I've written about, debuggers are at a buzzy intersection. They deal with unknowns from the external computing world on almost all fronts. And if one wanted a debugger to be useful for instance, extraordinarily large code bases, that highly successful companies use to ship real things, those unknowns include unfortunate details about these code bases too. I have to put a pause here because I've been actually, for a very long time, I've been struggling to explain what Automat really is. I keep saying it's a game automation system, a tool for game automation, which it kind of is. But turns out, kind of few programmers play games, and it's hard to explain to programmers what it is. So what is this? What is this system? So the one explanation I've been using recently is that this is a visual debugger. It's meant to attach to other processes and even to its own process and show to you, the computational entities within this register, this assembler thingy. This is essentially a debugger. This is basically dumping the registers. What the hell? Can I do this? What? This is crazy. This is crazy. And click stuff here. Anyway, so this is a debugger. So whenever somebody talks about debuggers, I kind of immediately feel this connection because most debuggers, they look completely different from Automat. They are text-based, but they have something very similar about them. This kind of connection to machine code or to code which is executing currently on the CPU. Something that's kind of live. We're trying to show something that's live effectively on screen. So yes, this is why I like everything related to debuggers. And the explanation that I'm giving to programmers now, what is Automat? Automat is a visual debugger. Let's continue. As such, in my work, making more effective use of hardware has been far more important than it ever has been for me in the past. As such, I was forced to address the elephant in the room, that is, CPU core counts and actually doing multi-core programming. True. Doing stuff in multi-core, it's hard because if you want to keep a reference to anything, the something can disappear at any point in time. Like holding references to stuff that is alive in memory is kind of a hard job to do. There is this ABA problem in programming, where you hold a reference to something. It's actually not only in programming, and that thing disappears, and something different appears at the same address. So now your reference is kind of still valid, but it points to an entirely different thing, entirely different object. You know, if you have a phone number for somebody, and that phone number is then reused, assigned to somebody else, no, it's still a valid phone number. You're not going to reach, your old friend by calling it anymore. Programming has the same issue. Debuggers have to deal with this. There are many ways around this. You can do some sort of multi-step pointers, where you point at something that's not going to go away, and you have, instead of having a pointer that points, directly to something, you have pointer that points to some stable reference, and then instructions that will follow a series of jumps. That's one approach. Another approach is to have smart references. So the object that you are pointing at can know that it is being pointed at, and it may reserve the memory, basically, so that even if the object is destroyed, there is some kind of gravestone at this address, so that if you come back, you can see, oh, this object existed, but it's gone. So at least you know it is gone. And debuggers have actually very little control over this. Anyway, I like the reference counting. Reference counting is very... I think it's the most efficient way to do this. And it works nicely with smart pointers and garbage collection. And it's also very efficient. But I guess in debuggers you cannot do this. In debuggers you probably need to do this stable reference and the sequence of jumps approach. Yeah. Okay, let's continue. I have learned a lot about multi-core aspect of programming in the past few years, and I've written about lessons I've learned during that time, like those on basic mental building blocks I used to plan for multi-threaded architecture. Okay, I'm going to save those articles. And carefully organizing mutations such that multiple threads require little to no synchronization. Okay. Interesting stuff, interesting stuff. I still find those ideas useful, and my past writing still captures my thoughts on the first principles of multi-core programming. But recently, thanks to some lessons I learned after a few discussions with Casey, my abilities in concretely applying those first principles have leveled up. By the way, I've been following Casey, but I actually had an impression that he's kind of making stuff up, because all of the examples that he was giving were kind of... So Casey typically criticizes some bad code examples, and he has this tendency to pick like strawman examples, like very bad quality code, which nobody would write. Yeah, I feel it's like fighting windmills. This is kind of like a Don Quixote of programming. He's kind of presenting those scary but totally made up examples and then fixing them in, performative way. Anyway, but maybe this is just how he kind of presents those examples. Maybe he actually has some interesting things to say. I don't know. I'm writing this post now to capture and share those lessons. The parallel for and its flaws. because every programmer learns single-core programming first, it's common after one first learns multi-core programming techniques to apply those techniques conservatively within otherwise single-threaded code, single-core code. To make this more concrete, consider the following simple example. We have some loop that computes a sum. Okay, this is the same kind of example that he would say Casey would present. He does some like parallelizing this. Of course, it's not going to bring you any advantage. Like you have to structure this for differently. This was supposed to be about debugging, right? Okay, I will just skip this because it's probably not even worth reading. It's just some, again, strawman argument about some silly way to do sums. Okay. That obviously doesn't win us anything, but what this means is that we can obtain the same result by subdividing blah 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 blah. Swell. Blah blah blah. Sorry, I'm just skipping some text. Okay, so what's the takeaway from these flows of force? You can implement them manually, yeah? Okay, so the argument here is that if you do parallelism at a very low level, for example, a single for loop, you have a lot of machinery that has to run at this very low level to parallelize something very small. So there is a lot of overhead for this extra machinery compared to, you know, the gain you get out of parallelism. Then we have the job systems. Is this going to be another example like that? Okay. One desirable property of the parallel for is that all jobs which execute at roughly the same time across some number of cores are identical in their shape. Each job thread participating in the problem is executing exactly the same code. We simply parameterize each job differently to distribute different subproblems to different cores. This makes understanding, predicting, profiling, and debugging such code much simpler. Furthermore, within a parallel for, each job's lifetime is scaled by the originating single-core code's lifetime. Each job begins and ends within some scope, the scope responsible for ranching, then joining all the jobs. This means no substantial lifetime management complexity occurs. Locations for a parallel for are as simple as for normal single-core code. But in practice, the mechanism often used to implement parallel force, the job system, is rarely only used in this way, which is understandable given its highly generic structure. For example, it's often used to launch a number of heterogeneous jobs. Heterogeneous jobs? In these cases, it becomes even more difficult to understand the context of a particular job, who launched it, and in what context. It also becomes more difficult to comprehensively understand the system because there is such a large number of possible configurations of thread states, it can be difficult to ensure a threaded system is robust in all cases. Yeah. These jobs are also often not bounded by their launcher scope, as such. More engineering must be spent of managing resources, like memory allocations, whose lifetimes now depend on what happens across multiple threads in multiple contexts. True. And this is really the tip of the iceberg. In more sophisticated systems, one might observe that there are dependencies between jobs, and jobs ought to be implicitly launched when the dependency jobs complete, creating an even longer and more difficult to inspect chain of context related to some independent through line of work. Okay. This doesn't parse in my head, but I think I know the gist. Okay. In practice, I found that an enormous number of systems are riddled with opportunities for parallelization because a lack of serial dependence between many of their parts. But if taking advantage of every instance, serial independence requires significantly more engineering than just accepting single-core performance, then, in many cases, programmers will opt for the latter. Again, does this mean that the job system cannot be used to do such a parallelization in those systems? No. But it also means that we pay these costs of using this job system. The more moving parts, the extra code and concepts to write, read, and debug much more frequently. If we'd like to take advantage of this widespread serial independence, or if we'd like any algorithm in particular to scale its performance with the number of cores. I'm not sure I feel like I get the spirit. Is that the system is kind of job systems are heavyweight and discourage programmers from using such complex machinery, maybe. Anyway, single core by default. Single core by default is actually a very good strategy for writing apps. It saves you so many bugs and issues. Like, code is so easy to reason about. I would honestly reach for multi-core only when single core is of not enough. And then I would parallelize at the highest possible level, so that, you do not write parallel force, but instead you parallelize different subsystems instead. The critical instant I learned from speaking with Casey on this topic was that a significant reason why these costs arise is because of the careful organization a system needs in order to switch from single-core to multi-core code. Mechanisms like job systems and their special case usage in parallel force represent, in some sense, the most conservative application of multi-core code. The vast majority of code is written as single-core, and a few carve-outs are made when multi-core is critically important. In other words, core remains single-core by default. In a few special cases, work is done to briefly hand work off to a multi-core system. Because the context of code execution changes across time, because work is handed off from one system to another, it necessarily requires more code to set up, and it is more difficult to debug and understand the full context at any point in time. But is this the best approach? Perhaps instead of writing single-core code, which sometimes goes wide by default, we can write multi-core code, which sometimes goes narrow by default. What does this look in practice? Okay, this is interesting. There is a good chance that you've already experienced this style in other areas of programming, notably in GPU shader programming. GPU shaders, like vertex or pixel shaders, used in traditional GPU rendering pipeline, are written such that they are multi-core by default. You author a single function, the entry point of the shader, but this function is executed on many cores, always implicitly. The language constructs and rules are arranged in such a way that the data reads and writes are always scoped by whatever core happens to be executing the code. A single execution of a vertex shader is scoped to a vertex, a pixel shader to a pixel, and so on. This way of programming, there are a couple programming paradigms which which try to bring programming to a much lower level, where you, instead of writing a complete program, you write a tiny grains of program, and you kind of combine those grains. And because those grains are kind of isolated from each other, they only communicate with neighboring grains, they can be parallelized very easily. There are propagator networks, which are they're not a very popular programming paradigm, but I've seen it used in Playbook recently, and yeah, they sound like a very cool approach, very cool solution, which tries to really reimagine programming at this very low level, at the level of individual computing grains. Anyway, let's continue. Because the fundamental underlying architecture is always multi-core by default, and because there is little involvement of each specific shader in how the multi-core parallelism is achieved, GPU programming enjoys enormous performance benefits, and yet, as the shader programmer, it feels that there are few costs to pay for it. So few, in fact, that it feels more like artistic scripting, to the degree that someone can build an entire website, shader toy, not just anyone, Inigo Willis, right? Built around rapid iteration, high performance visual GPU scripting. Wait a minute, high performance, rapid iteration scripting? It seems like many believe that these are mutually exclusive. Why does CPU programming feel so different? Contrast the GPU programming model to the usual CPU programming model. You author a single function, the entry point of your program, which is scheduled onto a single core only manually by a kernel scheduler using a single thread state. This model is, in contrast, single core by default. Long story short, it doesn't have to be. Multi-core by default. Let's begin by exactly inverting the approach. Instead of having a single thread, which kicks off work to many threads, let's just have many threads all running the same code by default. In a sense, let's have just one big parallel for. Bootstrap entry point. Blah, blah, blah. Okay, we launch threads, we join threads, and each thread has an entry point with parameters. To click into an architecture which assumes a single threaded entry point, we start with Bootstrap entry point. But the only work this function actually does is launch all of the threads executing the actual entry point. Let's consider an earlier summation example. I really don't like those simplistic examples. I think like all of the issues which come from multi-threading, which is like managing resources in a multi-threaded fashion, they are just not visible from those minimal examples. First, let's just take the original single-threaded code and put it into entry point and see how we can continue from there. So we computed some. This looks like just regular for sum, but this one is, I guess we started many threads like that. So we are computing many of those sums. What is actually happening? Well, we're computing the sum across many cores. That is technically true. Ship it. There is just one problem. This is just as fast as the single core version, except it also uses enormously more energy and steals time from other tasks on the CPU that CPU could be doing. because it's simply duplicating all the work on each core. But if we were to measure this and consider the real costs and profile the actual code, the profile would look something like this. Duplicated setup, duplicated sum. Duplication itself is not in principle a problem, and it is sometimes not to be avoided because deduplication can sometimes be more expensive than duplication. And this is actually a very interesting point. Yeah, maybe makes sense to compute something multiple times. Maybe we should actually start with this everything duplicated approach. For instance, communicating the result of a single add instruction across many threads to deduplicate the work of that add would be vastly more expensive than simply duplicating the add itself. We do want deduplication, but only when necessary or when it actually helps. So where does it help? Unsurprisingly, in this case, the dominating cost, the reason we are using multiple cores at all, is the sum across all elements in values. We want to distribute different parts of the sum across cores. To start, instead of, okay, we're just going we're just going back to our own job system. Or maybe it's not going to be a job system, maybe it's going to be some kind of a distributed without any kind of master to go coordinate work. So how do we fill those blanks? Who do we decide each thread's subset of work? How do we combine them? Values per thread, blah blah blah. Yeah, there is a little more nuance even in this. If you create this perfect partitioning of work among threads, and one of those threads is not scheduled, or it's scheduled on a slower core, you know, everybody else has to wait. So on a real scenario where you have a real computer that's doing the work, the optimal division of work is probably slightly more granular, and it probably has some duplication. Like if you're computing in a data center, it actually makes sense to send the same job to two workers because one worker it's just not reliable enough. But okay, we can do this even division. Okay, this is more succinct. Wow, this is like a very granular scheduling, which assumes you know how many threads there are, and the CPU is going to execute all threads at max speed all the time. Yeah, in optimal scenario, this works nicely. This is like, in optimal scenario, this is with no other programs executing. This is the best way you can do probably. You literally count how very precisely what's the range of items that each thread should sum. Combining all thread sums. Oh yes, and when we combine this, we can use atomic. This is how the original parallel for worked, like, right? Blah blah blah. Okay, and this is made up example. Nobody's doing sums like this. If you parallelize, yeah, the sum also needs to be parallel. Okay. Okay. Okay, there is some barrier. What kind of barrier is this? So this is something that makes sure no threads. This is kind of latch type barrier, or this is like a memory barrier? We are using an atomic already, right? This has a downside that only one thread group can be executing this code path at once. What? No. Okay, so this barrier is just waiting for all threads to finish. It's a join. It's a join, really. Okay, but this is just like a simple example. Let's see where it actually goes further on. Going narrow. Now, while I hope this summation example has been a useful introduction, I know it's a bit contrived and incomplete. Really complete. Specifically, it's missing two key parts of any program, inputs and outputs. What are we doing with this sum, and how do we use that in producing some form of output, and how do we obtain the inputs and store them in values and the values count? Let's barely extend the summation example with stories for the inputs and outputs. For the inputs, let's say that we read values out of a binary file, which just contains the whole array stored as it will be in memory. For the output, let's say that we just print the sum to stdout with printf. Printing out the sum will be the easiest part, so let's begin with that. What are we talking about? Okay. Oh, so every thread is doing the printf. I see. Oh, interesting. Okay, now this is getting interesting. So you actually write your program once and you just schedule it on all threads, and you put barriers. This is not an actual join, it's a barrier because all threads continue past it. Or it's a latch in C++, I think. So you set up a latch which has a number of threads, and they basically wait to this point and then they continue. So each thread will have I haven't read this, but I'm guessing that each thread is going to have a separate printf. Yeah, and you just check only one thread can actually print it. Very interesting. We simply need to mask away the work from all threads except one. I love this. This is such a silly way to program. But this is kind of how GPUs work. This is what you would do on a GPU. Let's consider the input problem. We need to compute values count based on the size of some input file, allocate storage for values, and then fill values by reading all data from the file. Single-threaded code to do that might look something like this. Standard code which will do this. So naturally one option is to simply do this narrow. If thread idx equals 0, do this, then synchronize all threads, and then continue. Very fun, very fun. I like it. A very fun way to program. Mind-bending. This will work, but we somehow need to broadcast the computed values out of values and values count across all threads. This is broadcasted. This barrier is broadcasting it. You just need to move them out of if, and that's it. So CPU actually has synchronization mechanism. When you put this barrier, like all of the cores are going to have access to those local variables. They can even be part of the stack or some shared stack across the threads. They could be global. They could be global. All threads would reuse them then. One easy way to do this is simply to pull them out as static, like we did for shared data earlier. Yeah. But consider that we might not want to do this completely single core. It might be the case that it's more efficient to issue file reads from many threads rather than from just one. In practice, this is partly true, although depending on the full stack, the kernel, the storage, drive hardware, and so on, it may not be beneficial as some number of threads and for certain sizes. So let's say we'd like to do the file reads wide now also. We need to still allocate values on a single thread, but once that is done, we can distribute the rest of the work trivially. Okay. So we do location in a single-threaded fashion, and then everybody's reading the file separately. Okay, the way that you would actually do this is you would map the file. File reading is so, like, 90s. This is 90s programming. If you want to read file fast, you map it, basically. You do not use read and write. It's much simpler now, compared to, say, the original parallel for case, to simply take another part of the problem like this and to also distribute it amongst threads, simply because wide is the default shape of the program. Instead of spending most programming time acting like we're on a single core machine, we simply assume our actual circumstances, which is that we have several cores, and sometimes we need to tie all together with a few serial dependencies. Or maybe reading is a good abstraction here, because we want to basically scan through the file. We do not need to pin the whole file in memory. Maybe it's actually not bad. Non-uniform work distribution. Let's take a look at our earlier calculations to distribute portions of the values array. Okay, this is this contrived splitting code. I'll actually put this in some kind of helper procedure, helper utility. This kind of stuff is, this kind of math is very reusable, I would say. There are probably many cases where you would want this kind of work splitting. It's nice to have a battle-tested implementation like this one. This was an easy case because uniformly dividing portions of values produces nearly uniform work across all cores. In a different scenario, we don't produce nearly uniform work across all cores. We have a problem. Some cores will finish their work in some section long before others, and they will be stuck at the next barrier synchronization point while the other cores finish. This barrier, depending on how it's shaped, it may actually give the control flow back to the kernel. So, not necessarily, but yeah, if you want to have full control over anything, you would kill all the other applications, and yes, then that would be a problem. You're wasting resources. This diminishes the returns we obtain from going quiet in the first place. Thus, it's important to uniformly distribute work whenever it's possible. The exact strategy for doing so will vary by problem, but I've noticed 3 common strategies. Uniformly distributing inputs reduces uniformly distributed work, the case with the sum, so we can decide the work distribution upfront. Each portion of an input requires a variable amount of per-core work. The work is relatively bounded, and there are many portions of input larger than the core count, so we can dynamically grab work on each core, so cores with complete smaller work can receive more, whereas cores that are stuck on longer work leave more units work for other cores. And 3. Each portion of an input requires a variable amount of per-core work, but there is a small number, lower than the core count, potentially very long sequences of work. We can attempt to redesign such algorithm so that it can be distributed more uniformly instead. We've already covered the first strategy with the sum example. Let's look at the latter two. Okay, they have been already explained here, so let's just skip them. Redesigning the algorithm, which is like the strawman. Okay, single-threaded, just better. Code which is multi-core by default feels like normal single-threaded code, just with a few extra constructs that express the missing information needed to execute on multiple cores. This style has some useful and interesting properties which make it preferable in many contexts to many of the popular styles of multi-core code found in the wild. Okay. Yeah, let's first start with the pros, because there is probably going to be some critique afterwards. Single core as parameterization. One interesting implication of code written this way is to be multi-core by default, is that it offers a strict superset of functionality than code which is written to be single core, because multi-core in this case includes single core as one possible case. We can use the same code to execute on only a single core simply by instead executing our entry point on a single thread and parameterizing that thread with thread index 0 and thread count equal 1. In that case, one core essentially receives all the work, barrier sinks turn into no-ops, since there is only one thread. There are no other threads to wait for, thus it's equivalent to single core functionality. Simpler debugging. Debugging is interesting. Does it actually tie into debugging? This style of multi-core programming requires far less. It's almost like simmed, but it's kind of like a manual simmed. Anyway, this style of multi-core programming requires far less busywork and machinery in order to use multiple cores for some code path. But one of the problems I mentioned with job systems and parallel force earlier was not only that they require more busywork and machinery, but that they are also more difficult to debug. I think the cool things would happen if you can do this if thread index equals 0 and you can go narrow. But it would be fun if you actually used this to break up some tree-based algorithms, You have 8 cores, and you have a tree which splits in 2. So the first 4 cores can go into one branch, the second 4 cores can go in the second branch, and you can recursively split this until you get to single core. Anyway. Okay, debugging is simpler, is it? At every point you have access to a full call stack and all contextual data which led to whatever point in time that you happen to be inspecting in a debugger. Like, to be honest, a lot of the heavy lifting comes from making some variables static. Because they are static, you can easily inspect them in a debugger. You point to them and you'll see their values. Not possible with stack located data and thread local stuff. Furthermore, because all threads involved are nearly homogeneous rather than the generic job system, where all threads are heterogeneous at all times, debugging a single thread is a lot like debugging all threads. This is especially true because between barrier synchronization points, all threads are all executing the same code. In other words, the context and state on one thread is likely to be highly informative of the context and state on all threads. But the state, the shared state, it's really shared through static or global variables, really. So this is what simplifies this. And I like global variables. I think globals are nice. It makes thinking about programs so much easier. Okay, access to the full stack. Because the context for some through line of computation frequently changes, in traditional job systems, extra machinery must be involved to pipe data from one context to another across jobs and threads and maintain any associated allocations and lifetimes. But in this style, resources and lifetimes are kept as simple as they are in single-threaded code. The stack, containing all contextual state at any point, becomes a single bucket for useful thread local storage. In a job system, the stack is useful multi-call thread local storage, but only for the duration of the job. The job is equivalent to an inner body of a for. This is a tiny fragmentary scope. With this style, the entire stack is available at any point. This goes back to using global variables. Codebase support. I found some useful patterns which can be extracted and widely used in code which is multi-core by default. These patterns seem as widely applicable as arenas as such. They can be a useful addition to a codebase's base layer. Thread local group data. Lane index, lane count, lane sync. The earlier example code frequently uses the thread index, thread count, and barrier variables. Passing those to every code path which might need them is redundant and cumbersome. As such, they are good candidates for thread local storage. In my code, I by the way, I have mixed feelings about thread local storage. It is amazing on one hand side. It's very efficient. It's using like a register effectively to access this thread local storage. The organization of this thread local storage is also very nice, but some of the algorithms that are needed to make it work are just, it's like reading Lovecraftian horrors. The amount of, complexity that you see there, it can drive you crazy. Like the stuff that linkers have to do to make them work. But yeah, thread local is nice when it works. In my code, I've bundled this into the base layer's thread context, which is a thread local structure which is universally accessible. It's where, for example, thread local Scratch arenas are stored. This provides all code the ability to read its index within a thread group, thread index, or the number of threads in its group, thread count, and to synchronize with other lanes, barrier sync. And it's a nice idea. I wonder if this allows you to split lanes. You know, this lane splitting would be nice. Anyway, as I suggested earlier, my code's caller can choose how wide, how many cores they like to execute that code by configuring this per thread storage. In general, shallow parts of call stack can decide how wide deeper parts of call stack are executed. If some work is expected to be small to the point where it doesn't benefit from being executed on many cores, then other cores can be doing some other useful work. Then before doing that work, the calling thread can simply set thread index 0, thread count 1, barrier 0. This means that a single thread might participate in many different thread groups. In other words, thread index and thread count are not static within the execution of a single thread. Therefore, I found it appropriate to introduce another disambiguating term, lane. Lane is a distinct from a thread, in that a lane is simply one thread within a potentially temporary group of threads, all executing the same code. As such, in my terminology, thread index is exposed as lane index and thread count. Well, uniformly distributing ranges amongst lines. Yes, lane range is basically taking this complex, mathy thing and putting it in some reusable utility. Yeah. Very useful utility to have. Broadcasting data across lanes. Earlier we saw lane sync the full signature. It's just lane sync. Earlier we saw that when, okay, it actually looks like an interesting utility function. It's like a dynamic latch, which only applies to the current lane group. This is my interpretation. Earlier we saw that when a variable needs to be shared across lanes, it can simply be marked as. I mentioned that this has the unfortunate downside that only a single group can be executing the code at one time, since one group lanes could trample over the static variable while another group is using it. It's fine, as long as you don't synchronize it, it's okay. Just don't tell CPU it needs to synchronize it, and it's not going to. As I mentioned, this is sometimes not a concern, since it's desirable to only have a single lane group executing some code, but it invisibly makes code inapplicable for some cases. For example, let's suppose I have some code which is written to be a multi-core by default. Depending on the inputs this code path, I may want this to be executed on the same inputs with all of my cores. But in other cases, I may want this to be executed with only a single core. I may still want to execute this code path on other cores, but for different inputs. This requires many lane groups to be executing the code at the same time, thus disqualifying the use of static to share data amongst lanes within the same group. To address this, I also created a simple mechanism to broadcast small amounts of data across lanes. Each thread context also stores, in addition to a lane index, lane count, and lane group barrier, a pointer to a shared buffer, which is the same value for all lanes in the same group. Some group storage, and this is used for this group latch. Okay. Revisiting the summation example. this reading file at several positions is actually interesting. Maybe it's actually better than ma. Yeah, I actually think it could be better. Then we perform sum across all lanes. Actually, if you do it like that, I'm not sure you really need to allocate the full buffer in memory. Because when you read stuff, you almost never... If you want to read the whole file, you map it anyway. And if you want to read the file in a streaming fashion, you only need like a tiny buffer, like a megabyte. You can allocate a megabyte per thread and use that megabyte. Well, this code still looks kind of strange to me. It's like, it's not sure which way it wants to go. Does it want to go this mapping approach, where you put stuff in memory and you just work in memory? Or do you want to stream data from files and compute stuff on the fly? Anyway. Closing thoughts. The concepts I've shared in this post represent what I feel is a fundamental shift in how CPU code can be expressed. It is a very interesting post. It is a very interesting technique. A genuinely new way to look at traditional C program, which is actually bringing some ideas from GPUs to CPU-based programming. Through small additional annotations to code, basic concepts like lane index, lane count, lane sync, all code can contain the information necessary to be executed wide, using multiple cores to better take advantage of serial independence. The same exact code can also be executed on a single core, meaning, okay, note that this still is not a comprehensive family of multi-threading techniques because it is strictly zooming on one technique, one unique timeline of work, and how a single timeline can be accelerated using fundamental multi-core reality of modern machines. But consider that programs often require multiple heterogeneous timelines of work where one lane group is not in lockstep with others, and thus should not prohibit others from making progress. But what I appreciate, I actually think this heterogeneous and this approach, they could work very nicely together, because you can do this lane-based dispatch to heterogeneous units of work. So it's not... I think it really fits nicely. Fits very nicely together. I think it's actually very cool to start your program in this multi-core mode, where the program will just start executing on 60 cores immediately, like from the point it started, and then it will just distribute different work to different cores as it executes, and it will execute in pretty much lockstep like it's doing here. It's a very fun way to do this. However, there is one issue with this style of programming. It's that almost always, when you are doing multi-threaded work, you have those stragglers. And because you have lane sync, your program is basically bottlenecked by stragglers. A single straggler forces all of your threads to wait. So, cool, you have like 64 threads, you are fully saturating your CPU, but there is like one job, let's say antivirus, which is using one of the cores, and suddenly your program is executing at half the speed because this single unit of work cannot be scheduled. Antivirus is running there, so your program runs using 63 cores. They complete immediately, and this last unit of work, it wasn't scheduled, it has to be scheduled again. It has to preempt one of your other threads and execute there. So this is... it's a very interesting idea, but I think preemptive, it kind of clashes with preemptive execution that all computers do. But it's still fun. It was a very fun read. Okay, I'm going to keep some of those other windows open, and I am resuming the TTS. And I will do a short break, so be right back. After I'm back, we are switching to this, fixing bugs in Automat. Okay. I'm back. Almost. I am back at in 50% capacity now. But this is enough to fire up some work. I think part of this work could be delegated to our friendly parrot, our friendly stochastic parrot. Okay. Fire up. Code editor. Anything queued? No. Think. Go. I actually. This first change is so simple that I'm not sure if I should do this maybe myself. Scoring poll. Render rescoring poll. And the poll in turns as board widget poll. And the board widget is part of an object toy. So I actually think poll should be part of this, but okay. Or actually maybe this should be a function on toy. Okay. I will let it work. So be right back. Okay, I'm back. I see there is some code being created. Let's look at the next issue. Spotlight connections. It's drawn over its endpoints, yes. I think this spotlight it's actually a very strange case. It's drawn over. I have this enum with connection types. Should be here. Yeah, I do not put documentation in many places, but when I do, I make sure it's obsolete the moment after it's written. Streams need to be separated out already. Let's go to draw. Okay, I have a completely separate type of connection called connection spotlight, and this is how it should work. And it's super simple. So ridiculously simple. I'm wondering. How can I be doing so much? Okay. Okay, so here is what's happening. If when connection widget ticks, it checks its own style and creates a connection widget which is layered under the connection itself. Now, this code is ugly. Wow. I'm kind of ashamed of this when I'm reading it now. I have this separate nice class called Connection Spotlight, and instead of using it properly, I have this kind of spaghetti here. Ooh.
My chess engine is evolving.
URL.
Did they fix the bug that you reported? You know, the cheat.
I don't know.
How much is this GIF? $300. Hey, not bad, not bad.
But your TTS is not displaying GIFs anymore.
Maybe you uploaded it differently last time? Yeah, it's on Discord. Discord should have GIFs. Interesting. And now it worked. This is a different game.
So, it has to be filed directly. Same game.
Who are you playing with here? Is this some kind of stockfish opponent? Oh.
It's Maya Engine versus Maya 3, rated at 1900.
This is totally beyond us, humans. I have no idea what this parrot is doing now, but I will let it continue. Like, I actually thought it's just going to add like a virtual functions in every widget. One virtual function. It's doing something strange.
2,823 is Magnus's rating.
Yeah, totally average human rating.
Average Angry Viking rating.
fix this bug with connection, the spotlight connection. This would be... strange. This connection needs to be changed somehow.
2775 is average Slavic chess rating.
Do we count the bots?
Achieved by none other than adopted Krot Gary Kasparov.
What is it doing? Okay, I am going to interrupt this.
Have you considered using DeepSeek? It's just distilled Claude.
It's a more compliant Claude.
It's our Claude. Long live CCP Padway.
At least you know, making those models free is like probably the most ideologically consistent thing they could do.
You know I don't trust these capitalist-based companies. They sell your data, at least these commie-based companies share your data.
There we go, register widget. Looks nice. Looks okay. Assembler widget. Yeah, also very minimal. So a connection between them. There is a connection between them. This connection should be drawn beneath them, I think. What the heck is going on? Why is it so slow? I was watching Doctor Who recently. They have this adorable race of aliens that wants to exterminate every living being. Daleks. And they have this wonderful way of speaking where they can only scream. So they ride around like those giant Roombas and they scream, "Obey! Exterminate!"
You forgot make no mistake.
It's very annoying when I tell it to just... When I say deliver to origin, it means to copy the work from the VM. The parrot works in a VM, so it cannot mess up my operating system, into this special directory called origin, which is the Automat source code. It just doesn't want to do it. It just does its own thing.
So no SS keys leak.
I actually have a very special command for mounting my file system in a... So this is a very roundabout way to mount a remote file system, but this allows me to connect to that machine using my local key without sharing it. I create this reverse port mapping, and then I do SSHFS mount. In this kind of reverse direction. Anyway, I can mount my directory without exposing my keys to this machine.
There is simpler option, you know.
What's that?
User with UID 1001 and GID 1001. Then from default user 1000. You log into it with Rardabux perms and run Claude as use 1001.
I do not trust... so first of all, it's going to use sudo, and it's going to need sudo sooner or later. I just treat the whole VM where Claude runs as compromised. Like you're running a piece of malware. This is how you should approach this. You do not run a piece of malware with a new user, just asking for trouble. Okay, this poll is very... compares the pointer? Shouldn't.
Linux can run malware. Impossible we make malware. Malware is for those windbloats peasants.
Linux users will happily run random curl and pipe to bash, random curl commands they find online and pipe them to bash.
QRL script, sudo h-wipe.
Yeah. This is incredible that it works, and that, you know, everybody does this. Honestly, there is not much difference between this and just running random executables, which people do, or just downloading packages from pip or npm.
Well, it's totally reasonable.
And this is why people buy domains. This is why people love to buy used domains, especially from software. Hey, this is actually quite a bit of refactoring. I do not like when it deletes my comments. I wrote this comment. I want it to stay.
NGL, I kinda wanted to wind in my cybersec skill so I could mess with scammer. You know, like DDoS and scammers.
I think there are plenty of Trojans. If you can get some kind of... you can probably download them online. If you can attach a Trojan to something that they will run, that's the best outcome. This gives you the ultimate control over their, you know, life for the foreseeable future. And DDoSing is, you know, it's not really interesting if you compare it against, you know, other things you could do. Okay, so we now have this toy poll.
Other things, like Peroni does.
Is this about Formula One? Because I'm not in this, no, I'm not part of this world.
Peroni, the scammer. Preview. The guy who scams scammers.
Yeah, I wouldn't be surprised if he used some malware. Or like, because those scammers, I remember correctly, they use some remote desktop software. Okay, and that looks fine. The implementation looks fine. Okay, this will call poll on the board widget recursively, so we do not need this. You only need to poll action. Yeah. This is an important thing to remember. Poll and on poll. I will actually split this into two.
I received email from my own email, but message is not in sent directory. I wonder what it can be.
They are really targeting you. And this on poll will be empty by default. No implementation. And I actually think it probably makes sense to make this whole poll inline. Or maybe no. Maybe. Go to root widget. Root widget has just a regular poll.
Two phone calls, I give them IPs of the servers, and let authorities handle it.
Did I fix this? I should have fixed it. action. Was an action. Okay, action can have just a regular poll. This is fine. Okay. Should work. So we basically split poll into a static and a virtual parts. No. I'm trying to maximize the static code and minimize the dynamic part. Dynamic is only what's necessary. What has to be dynamic. And it should work, I think. So if I put an assembler here, something like this. Yep, it updates instantly. No delay anymore. This polling, it may seem like, hey, it's a lot of work. Every frame I have to ask an object, but it actually is being polled only when it's on screen. So the moment I move my screen outside, polling stops. Yeah, only when I'm here, I am polling anything.
FireEyeGunsPackaging.com. This domain seems to be expired and bought by Botnet.
It is running now, even though I deleted the assembly. Can I stop it? Okay. I managed to stop it somehow. Okay. So that was the first bug. So registers are now properly updated. How do I cross stuff in Markdown?
Bunhouses says,
Bug hunter.
You just have to. It's a bug hunting Wednesday. Otherwise we would be just covered in bugs. Yes, I am a human. I'm just using incognito. Tilde? Double tilde? Okay. It doesn't seem to be standard.
Meister Chica says,
Or spam hunting Wednesday game.
How was this called? It was called Spotlight Connection? Connection Spotlight. smaller action widget.
And I wouldn't be reading and looking my recent emails if Khaled didn't open link from Faizan email yesterday.
Opening a link is enough? This is a scary world we live in. You know, one misclick and they can kind of compromise your data. Is this possible? Do browsers allow this?
Browsers still allow for auto-download.
So you click a link, you download some random file, then you open this file, and this is how your PC gets compromised. Because I know once you click this, you know, they can show you whatever they want. Like the website can be crafted to look perfectly like, you know, your own email. Okay, there is actually, yeah, I completely do not understand why this is drawn in the wrong order. So this is, for example,
Good thing we have downloads locked down. They first go true cybersec teams.
the spotlight should be in the back. Should be in the back. Is it in front?
How does Google deal with such mishaps?
Like running a malicious code? They must happen. I do wonder. I mean, I've been literally sitting next to the hijacking team. We did mostly work with, not on Googlers themselves, but we dealt with just regular users being hijacked. I think secure boot, definitely. This is like one part. And there is a custom distribution of Debian that I think it was Ubuntu actually that Googlers use, which is probably also using signed code. So I suspect there is a lot of code signing happening along the way. But you can run random software on those laptops. It must be happening. You know, a company this large must be in a constant state of compromise. You just do not know where it's happening, but you can be sure it's happening somewhere. Okay, I see. This is honestly not a bad idea. I want to refactor the whole thing, but I think whatever shape I end up when refactoring connections, so they do not use this. Oh, this gruesome logic. I think the helper function is going to be present in this refactored state anyway.
Theoretically speaking, what would be the impact of Google Central Infra being locked down by a BitLocker?
That would be fun. I actually wonder if it's going to be even possible to pay the, ransom if the DNS is down.
First of all, no you.
Yeah. I'm slightly afraid of too much refactoring, but
Okay, so YouTube goes down. Everyone goes to Twitch, Amazon makes stunk, then what?
I'm not sure if many people would be able to go to Amazon, with like a large part of DNS is not really that. DNS is hierarchical. It's not really super robust to, you know, failures close to the root.
Oh, heck, Android users are kind and deep if that happens.
Yeah, that's one. And there are other people who also rely on... So honest DNS is this name of the DNS that Google provides. Lots of people use it.
What about S7 protocol access on phone?
Is it 7? Interesting. I had no idea of this protocol exists. It sounds to be quite old.
Is it possible that like 80 world's population won't be able to contact emergency services?
I think phones are slightly more robust. You know, this is why when you are an on-call at Google, you do not use internet to receive alerts. It wouldn't make sense because yeah, internet can kind of stop working. Like, that's the point. So alerts are delivered through pagers, like traditional pagers. Like SMS messages, actually.
Tell me I have 4 of those in-house.
Yeah, but this is the right way to send alerts. Like, if your computing infrastructure is to be protected, it really doesn't make sense to send any alerts using the said infrastructure. It was a cool article. There's a lot of typos actually. And shapes of computation. I like this. I already like this. Yeah. But creating those drawings, trying to create a drawing that represents a computation is, I think it's a very interesting exercise. What may not be, entirely visual, but a little part of them is. It helps to be able to see it in front of your eyes. Makes it easier to store a larger amount of code. Because you do not have to store it in your head, you can dump it on paper. And it's easier to see things that are happening. What do we have here? Instruction is a dot. Advance is an arrow. I don't know what kind of advance it is. Is it like causal relationship? Maybe. And a thick arrow is a read/write, and data is a sheet of paper. Okay. So those are instructions that read and write, okay.
You know that MLL diagrams are made to be drawn easily by hand, and not by computer.
Yeah, if they were meant to be drawn by a computer, they could use so many cool, features, gradients, textures. It's having color. I think color is unused in UML. But it also would be nice to draw UML kind of by hand, but with this like excessively artistic style, where you, instead of just drawing a box and text, you could actually decorate the box a little bit. Or maybe more than a little, draw some, symbols around.
XML-based diagrams, that would be nice side project idea.
Okay, so this arrow looks like this is control flow. Yes. There is no control flow. I mean, this, like a sequential execution is a control flow.
Because XML is more or less used everywhere, and is already structured by default, so you just need some rendering to be done.
Yeah. You could say browsers do this. There must be a finite number of instructions executed, because the code path must terminate. Why? Code paths that terminate are boring. Like, I prefer code paths that never terminate.
Isn't ATL just extension of XML?
Or nobody knows which way it actually goes. But yeah, one of them is extension of the other. It may be a recursive thing, you know, like in the Back to the Future, like HTML extended XML and XML extended HTML. So HTML is the parent of XML and XML is the parent of HTML.
Well, HTML does not have self-closing tags.
Or the opposite, right? XML. But even then it depends on, you know, there was HTML also at some point.
HTML does have self-closing tags. XML.
Yeah. Oh, so code path goes from A to B. It can be wide. And if we have a loop, that's a code cycle. I see.
Even I don't know which has what.
And what is this? It looks like Debian logo. Wide code cycle. Those are different code cycles. This is a writer, this is a reader. Those two, and writes this one. Okay. I think Ryan is kind of slowly moving towards an architecture that Paul Tardivas describes on his blog. Find it. He's a prolific writer that describes. I think Paul is much deeper in this rabbit hole. He has his own kind of programming methodology called parts-based programming, which kind of tries to look at computation like that. As a kind of like hardware, trying to think of computers like chips. Basically, they don't quite send messages, but they communicate with other chips. Okay, that was a very short article. Okay, how are we doing here? Chassis state. Oh. By the way, this stream garbage is something that Claude added. Kind of ignored it because it needs refactoring anyway. But yeah. This is beautiful language, but I don't know what it means. Talking with Claude is kind of like that. It makes me kind of feel nice, but I'm also suspicious. It makes me look for red flags in this explanation. Okay, so it says extract the splits maintenance tail into what is splits maintenance table? Okay, it is also duplicated in sync.cc. Interesting. 489. Okay, this is part of sync belt. Sync belt is kind of like a connection. Yeah. I'm actually worried about splits. I'm not sure if other widgets are compatible with splits. think sync belts are also pretty much connections. I go to sync HH. And it's syncable here. Gear is an object. Blah blah blah. Sync belt argument type. Connection widget is also an argument type. Why is it called stream? I would like to call this pipe. I think pipe is way better. Hey. Mm. Yeah, we have practically unused argument.cpp, which just seems like the place to put everything. This is already argument toy. This is argument toy. Yeah. I think this wheel, there's this problem, and maybe some others as well. I'm so happy with the new shadow system. For example, look at the shadow of this rose. It's actually accurate. You know, it only shows where the actual rose is. Actually, I read this. I think I'm actually kind of afraid that board is probably using connection widget a lot. Argument make toy. Yeah, it's a connection widget. Interesting. So this would be a switch here. It's doable to actually change this. Invalidate connection widgets. Three invalidate argument toys. Argwake toys. Ah, like I really like this when things are kind of falling in their places, and I feel like this is happening right now. Invalidate connection widgets everywhere. Interesting. It's scary sounding function. And this UI connection widget, yes, it also has some code like that. Okay. Okay, what is happening here? A real benefit? Yes. Disappears, true. I know this. Things that belong in the base, every single needs them. And endpoints without an hide logic, routing. Routing is not really splits. One decision to make. The radar and the prototype goes belong to auto-connect arguments, not to anyone's style, so they go in the base too. Holding them in means the whole connection redraws while the radar animates too. And its texture grows, the radar's bounce. This radar is really a problem. I actually had this idea to get rid of the radar and have a separate radar object that would do the auto connections. Could exist. That could work. Is radar a separate widget? Collect radar. Order below. Yes. Wonderful. Mhm. Okay, this is a bigger change. Stuff like this will probably take something like an hour because the parrot needs to read the code and probably go through several rounds of testing. So I think I will cut the stream here. But we haven't finished with everything. There is also these hotkey buttons. So while the parrot is working on that thing, we can probably fix the hotkey. Hotkey is going to be super easy to fix. I hope. The idea is that when you press any of those keys, let's go here, the hotkey in here. See, I click this, it didn't update. Only when I move my mouse out, it receives notification. Let's see how widget is created for this. This is hotkey widget. power button, blah blah blah. Okay, this is what happens when we activate those buttons. First we lock the object, we flip it, we change the foreground, and we also need to activate it. E. Or maybe not. I actually think we should wake animation with the current time. Yeah. Windows. Wake animation. This is also interesting. Shortcut button. We are calling quick animation here. It's strange. Let me rerun it. Hey, it is not updating. I'm clicking. Clicking. Ah. Even though... Can we have this? Okay, I know. I'm calling wake animation on this button thingy. I bet the tick is broken here. Where is the tick? Tick? No tick? Out of the button, I see. Cable.tick. Is used for highlights. This node wants to draw. Okay, the issue is that we are not returning the drawing bits. Hmm. Our button is waking. Calling clickable tick. We are checking this foreground color, which is actually something we could. Okay, this is the frame. Baked children? I think those should be drawn over, right? Okay, they are not baked. This baked children is... it's not necessary, really. Everything should still render properly without it. This hotkey isn't really changing at all. Ground, it's all fixed. It's a fixed drawing. Shade alpha 0.5. I don't see any animation here. I actually think we can do nothing here. A very fun hotkey. Shift. Anyway, I need to make it return draw from its. In this wake animation, we don't need it. I think. Or maybe we do. Yeah. The button has a child called the label widget. For some reason inside. Okay. Okay, it has no color mixing, so this path is not active. Okay, draw the face. Okay, I think I will just override this stick. It will address all of the issues. Okay, this is fixed. Seems to work now. Great. Am I using those keys anywhere else? I think here. Yeah, and this one also works now. or not. Okay, let's go back to the drawing board. What happens when I call set label? That did not help. I do wonder why. Yeah, now suddenly it's not updating anymore. Interesting. Depending on the key, it sometimes updates. Library key presser. Oh. This function is deprecated. It should not be used anywhere. Should instead call wake toys. Presser widget tick. has this timer in there as well. Like that. It's a very strange structure. Timer is necessary for change propagation. We need the current clock, basically, to do this safely. It's a strange consequence. It's not working. I'm calling set label. I do have timer. Who is the tick looking here? I do not see tick. Aha. That should fix it. Oh, there is set label here. Maybe I don't need this wake animation multiple times. not much difference, but now we can easily pass timers around. Or no, I will not pass no TTR here. Okay. Things are working. This one. This is an interesting bug. Somehow we didn't receive the D key. And this works. Okay. Key updates. This is what all that matters. This and code quality. Yeah, I think a lot of wake animation add could be migrated to wake animation now. Next tick is less than equal now. Then we enter this, and we are stealing this now from timer, so all is going to work nicely. We also use last here. Could not pass this timer. It would still work. Passing timer makes the animation more responsive. It makes the same frame update possible. I think I can actually amend this into the previous CL. It's a good idea. Okay, I guess it was. It's fine. Okay, actually... Somehow it deleted the important code, and it didn't notice that we are not using arrows anywhere. It didn't delete arrows. Okay, tick refusal runs for arrow and a cable. Just show user. I'm not sure what's tick refusal. I guess it's fine. I think drag connection action should really be drag argument, maybe. Sync bell, sync action. Okay, we have a special action for those. Do syncing across boards. No, we are not interested in this. It's so hard to work with AI. It's kind of... You cannot really tell it what to do because it's going to tell you, take your instructions to the extreme. You tell it not to delete code, it just stops deleting any code. You tell it to delete code, it starts deleting the important code. It's like, it cannot distinguish the important from unimportant parts of code. Cable, routed cable. Okay, okay. The idea with this routed cable was that yes, it was smooth. And this is how it looked. Okay. I think it's going to test it in a second, so let's see how it will look. There's no cable there, but I think you need to move the macro recorder before the cable shows. Maybe it forgot something important, who knows. So this hotkey is fixed. So let's think about what's next. All of the bugs I kind of encountered seem to be fixed. This works. This almost works. I think there are some issues. Yes, this prototype doesn't disappear. So we shouldn't really have this. For some reason, this prototype acts as a receptive field for this connection. Shouldn't be like. Excuse me. It shouldn't be like that. This is working super nicely. This is working nicely as well now. This is fine. It's actually very nice. I had no idea I can actually create new objects straight from the toolbar. This works here. It's so fast to use. Okay, we have this calculator which is not doing anything useful. Timeline, yeah, we looked at the timeline. We have this. Okay, there was a bug in assembler. And actually there are a couple of things that we should fix in assembler. So maybe, let's see, what am I doing next week? Okay, on Friday next week I may be out of town. But if I'm not out of town, I'm here, then I would like to fix some of the annoying things that have been bothering me for a long time in assembler. The idea with this deck of cards was that when it's in the toolbar, it should actually be minified, and this deck, when it's minified, it should have no filter here, so this should be invisible. I can iconify, but it's just looking like that. And all of the cards should basically fold into a single nice deck with a top card saying x86-64 or something like this. Or Intel, or something like that. I know, maybe it could be the name of your CPU actually. It's possible to read this. So if we can call the CPU ID, maybe you can put the name of CPU manufacturer on the deck of cards. So yeah, I think the plan for the next stream is to convert this. First of all, I will fix the shape of this widget because the shape is a huge circle. You cannot see it, but this is the shape of this widget, awful. And we will add a minification animation to this. Sounds like a plan. And then, oh, we have way more things to fix. Okay, this part looks like it's pretty polished. They seem to be working pretty well. We just need to fix the assembler. I even have an idea of how this could work. You know, when the cards fly out, they have this flip. So maybe when we minify this, when we iconify this, we maybe could just make all of the cards fly like that. Then we will end up with just like a vertical deck here. And the image on the back is going to include the name of your CPU, whatever CPU you have. Okay, sounds like a plan. Yeah. I actually think with all those fixes that we've done right now, I could actually put assembler and window capture into the beta directory so that they are not, you know, so that you don't see them all the time, because they are kind of unfinished. Maybe even timeline, I could maybe hide the timeline. This number, who needs this number? Maybe with this, Steam would work. I also see some glitch in the toolbar animation. Yeah, there are some weird things happening with the toolbar. Okay. So this is it for today. See you on Friday or possibly next week. Bye bye.